Sorry, somehow it got muted for a second. So I was saying, if the token is a big token and it's sent in the HTTP headers, you watch out because there might be proxies that limit the size, and then that can make for some very hard debugging. Um, but you have to be aware of it. Ideally you want to keep the token small, and if it's a big token, maybe you have to send it in the body of the post, or you have to send it some other way,
Right.
than using the headers.
Yeah. But I mean, I really like the idea of down scoping the tokens based on content and claims rather than trying to bind it to something specific,
Yeah,
some kind of physical channel. Because at the end of the day, we're at KubeCon, right? The entire point of this is, abstraction away of physical infrastructure to the point that as a developer, I don't worry about it. Right?
true.
If I'm deploying an API, if I'm deploying a micro, whatever it is, whether it's a monolith or a microservice or a regular service, I want to just be able to say, here's how I do the authentication and be done with it. And what going to down scoping does is it makes it really easy for us to, as security professionals, say, okay, you need to do your work, right? But we're going to authorize it before it even gets to you. This is something that we can plug into an API gateway. This is something we can plug into an external authorization. So we were talking about, Cerberus and
Cedar Link, my favorite
right?
topic.
Yeah, and so being able to say, hey, there's enough context, there's enough information in the token to make the decision on its own. Because the worst thing is in the world is having to reach out to something else, right? That just drags down your transaction time. So we've got that down scoped information in the token. We can make that authorization decision and then unload it off the developers. Because quite frankly, I know we like to talk about shift left, and I get a lot of flack for saying this, but if you're relying on your developers to implement security, you've already lost, right? Like, secure coding is important. Teaching developers good hygiene is important. But if you're relying on your developers to implement this stuff correctly, you just might as well pack it. You're done. And so being able to handle the authentication and the authorization before it gets to your API, that is a big W. I think down scoping is going to be a big part of it.
Yeah, and down scoping tokens has always been the dream, but how you actually do it has been sort of like left open to implementation. So, it's good to see this pattern is taking off a little more. Part of what you said about the developers struggling with security is definitely true. I feel it in token validation, where token validation is getting more complicated, and I see inconsistent token validation, where if there's one issuer, then validating the signature is not that hard. But if you have multiple issuers, then that's going to be more complicated to explain to the developers. New features, like different tokens have different claims in them. Some of them have expirations or NBF claims.
Oh, I hope they have expirations.
And so do the developers always check all? It's not just the expiration, but it's like the NBF if it's this type of token, I'm expecting an audience of this, value. And so I think going this next level and explaining what the contents of the token should be as we introduce more and more tokens, expecting them to understand what those contents are going to be for all those new tokens is challenging. And then finally, token revocation. There's a new OAuth draft that should be standard very soon that allows you to define token status lists for an IDP to publish that it's going to revoke a token before expiration. That's something that I'm not very optimistic about developers wanting to do. But if we can move that into the infrastructure, I don't think it's a big ask for the infrastructure to check the expiration or to check for revocation.
And that's the great thing. I think that's a big reason for a lot of that is, again, we're at KubeCon, right? We're not at an identity conference yet. I've seen at least half a dozen vendors focused on identity because it's an important part. Because now that you have all that automation, you have to have a way to identify those workloads. And so, whether you're talking about the identity at the infrastructure layer, the identity at the application layer, because you're automating it, that gives us a opportunity that we have not had. I mean, I'm coming back from my Integrity and Obelix days where we had agents on it, right? And the
Mhm.
agents all just magically worked. I mean, it wasn't magic; it was pain, blood, sweat,
It's hard
tears.
to update them.
Yeah, but the fact is that once you installed the agent, you had something there. That doesn't exist, right? Everything is now standards based. It's all heterogeneous. So being able to have those standards and then saying we're going to implement it at a layer above where it gets to the code is a huge W. And then having a way to be able to plug that in without the developers having to do anything other than, hey, let me know who the user is or what the user is if we're talking about machine identities, right? Like you were talking about before, earlier today, we were talking about how a lot of authentication is not users, right? It's machine
Right.
subjects.
Yeah, I was going to go there next to workload identity. And so I heard a lot of mentions of Spiffy. I hear a lot of projection of hopes and dreams on Spiffy too. So, but what are your thoughts about workload identity now? Um, there's a couple of approaches. There's Spiffy allows you to define to register, let's say, a workload and get an identifier, a certificate where they put the identifier in the SAN. And then there's a new OAuth draft called Client ID Metadata. I just did an episode with Aaron Parecki on this, where the client could self-assert a URI and provide a metadata document there.
We're partying like it's OAuth 1.
Yeah. And then actually, we were at a session today, the Kubernetes authsig, and they were talking about delivering certificates into pods.
Yep.
And I was wondering to myself, what would be the identifier of that certificate? What's the subject name or SAN in that, and how is that obtained? Do they do Spiffy and get it before? So it seems like workload identity is kind of a toss-up right now, and the agents are struggling also with this challenge of how do they bootstrap an identity. So what are your thoughts on what are the right ways to actually, what should your workload do? What should your
So I'm
Kubernetes
going to be a little controversial here. I think Spiffy is a legacy technology, or at least Spire is.
Yeah.
The more I look at it, the more I work with it. It's a great tech. So let's talk a little bit about what Spiffy and Spire are. Spiffy is a specification, simple something.
Yeah,
identity
our
for
audience
everyone.
knows about Spiffy.
Yeah. But it's a way to define initially certificates, right? What's the format of a certificate?
Mhm.
And then they added tokens after the fact. And then Spire's the kind of reference implementation.
The registrar, really.
Right. And one of the things that made Spire so important was it also became what issued the identity,
Mhm.
right? So like the original versions of Spire, you would launch a workload, and because the workload didn't have its own identity, there were fingerprinting systems that were in place that would fingerprint the workload and then assign an identity, whether it was based on IP, based on hardware. There was like 20 different things you could base it on to do that fingerprint and generate an identity. That's not really necessary as much today because everything has an identity. I mean, not everything, but almost every workload out there has some way to identify itself.
Are you talking about
service.
attestations that might come from the from either the hardware or the operating system, or that a workload could generate that might have an identifier? Like, I think I agree with you about Spiffy being legacy. I think even the Spiral guys agree with you about that, because that's why they're collaborating on Whimsy, which is sort of the next generation of Spiffy. I always saw Spiffy, one of the challenges of Spiffy is that it bootstraps the identifier, but then there's no way you can't authenticate. It
Right.
doesn't provide you the authentication piece. So you could use Spiffy to get the URI and then perform dynamic client registration and hopefully assert that URI as your client ID. So we never had an answer for where the identified client ID came from. So it provides a good solution for that.
Yeah, and that's why, like in the Kubernetes world, pre-Kubernetes 124, you had a service account for each pod, right? Every workload had a generic identity, right? If you had 3 instances of one deployment, each one of them had the same identity prior to 1.24 because it was bound to the service account. a service account had its own unique identifier. Starting at 124, and we're on 134 now, so that's 10 versions of it. Each pod gets a unique identity. So your identity is not just what service account you are, but which individual pod you are. So you can validate whether or not a workload is even still in existence, right? So if I've got that identity, I don't need an additional bootstrap to issue an identity. I need a way to securely transform that into an identity that works for whatever I'm going to call. And I think that that's where the future is because more and more services have their own bootstrapped identity, because you have to have it in an automated environment. I mean, Amazon's been doing it for years. All the cloud providers have been doing it for years. VMware does it now. Like all of these systems, you have to have identity in order to do the automation. So we're going to piggyback off of that identity instead of having to layer on some kind of additional identity layer to be able to get to where we need to go.
So that's a Kubernetes identifier. And how does the workload get that identifier?
It gets issued by the API server. So, when the API server launches a workload, it mounts in an identity. It's called volume projection. So it projects an identity, which is a jot, and you can control how long that jot is good for. I think by default it's like 24 hours. So when you validate that identity, what's really important is you don't just do your typical jot validation. You don't just say, okay, well, not before, not after, audience, etc. You also have to say, well, is this workload still good? Like, is the workload still going? Because what you don't want to happen is like, oh, there's a bug in this API or in this app that allows for abstraction of this API, or for this jot, and now I can go use it on something else, right? You need something that's going to bind that to the workload. And so you can go to the API server and, hey, API server, is this a valid workload? Does this identify a workload? No, this workload died 2 days ago, or 2 minutes ago, right? Okay, I'm not going to do a transform at that point. So it's really giving you that capability to be able to, tie what's going on to the workload. Kubernetes does that for you automatically, and so that becomes really important now, so that your APIs have an identity of their own to go talk to other services. Now, the classic example that they like to use in all the documentation is, I want to go talk to Vault to get secrets. Okay, so if I'm going to talk to Vault to get secrets, I'm going to use my own identity instead of a service account that's stored in a secret manager, because that'll be a little difficult to get your hands on. So you can project the token with the right audience, and then go ahead and just validate it. Again, you need something, though, that's going to say, is that token still part of that workflow or not? And I think that that's going to become more and more popular, to be able to say, all right, I'm just going to leverage the existing identity into a token exchange rather than trying to project a new identity on top of what's already there.
Great. So I wanted to ask a follow-up question on the session that we were in. They described some new capabilities in Kubernetes to map claims to, I guess, entities in Kubernetes. I was just curious about your thoughts on that. Is that a good idea? And are they going to go far enough in sort of the features that they expose? I'm just curious what your thoughts on that part of the presentation were.
Yeah, it's actually a really great feature that's going in, because Kubernetes prior to 1.34, at least GA, could only support one issuer. So if you had multiple sources of identity, you had to layer something on top to do it. So as an example, we do it for our multi-cluster management, where if we're going to talk to the remote Kubernetes API server, instead of getting like a service account token and like rotating it on occasion, we would set up a Kubo IDC proxy. Now, this is a proxy that we maintain now that will authenticate based on a token. So we say, okay, this proxy is going to authenticate these API calls from our Open Unison identity provider. And so any token that gets generated from that is going to be properly signed, have the right, not before, not after, and it's very short-lived because we only use it for one transaction. That then goes ahead and runs impersonation, which is injecting headers about the authenticated user down to the API server. So a couple problems with that. One, That's an additional layer of infrastructure with that proxy. That proxy is not particularly heavy, but it's still, something the ad management can do. And two, impersonation is a privileged process, right? If I can say I'm other people,
Yeah.
that's a dangerous service account. And so having that service account in a proxy can expose you. You want to be careful with that. And so by eliminating the need for that, you're gaining the capability to be able to do more automation, to be able to do more from different systems, but you don't have to worry about that additional proxy. Now, of course, what's going to be interesting is it's going to take time for this to make it into, especially the cloud providers. I mean, all the cloud providers have said they're going to support. It's called structured authentication. So they said that they're going to do that. They're not entirely sure how, but they're going to do that. But even then, things get iffy with it. So, as an example, like EKS, Amazon's Kubernetes, has supported OIDC for a few years now. I think since 2020. But it has to be a publicly signed cert. So it's basically for like the Oktas and the Entra IDs.
They have a limited list of certs that they trust.
It's
basically.
not even a limited list, but it has to be a commercial cert. It has to be available on the internet.
Mm-hmm.
So if you've got something, if you've got a direct connect and you've got an automation process that's running on-prem and it needs to talk to, it needs to talk to your EKS cluster, you can't, like those two things aren't going to work.
Right.
So you still are going to need some kind of user layer on top of that. So it'll be interesting to see how that works. Another nice part of it is it gives you some basic authorization using CEL.
Right.
So you can say, not only am I going to only authorize an audience, but I'm going to authorize potentially specific claims. Like I can say group management or scopes or whatever. To be able to narrow down which tokens we're going to accept into our API server. So there's a lot of capabilities there. There's a lot of potential there, and it's a feature I've been excited for a while.
Yeah, and I guess my last question, DRA, Dynamic Resource Allocation.
That's a new one,
I'm getting this right.
Yep.
That sounded like a very tempting feature. So I think part of the idea is like, okay, I want a CPU, but only if it has these properties, and I can get this type of CPU.
Not quite. So the when you launch a pod, when you launch a workload onto Kubernetes, the pod cannot be changed. So if I allocate a pod that says 4 GPUs and a CPU and 2 gig of memory, as an example, and as it starts processing, these inference pods, they run a while, right? Like they're crunching a lot of numbers, and you start to see that these pods are hitting that upper edge. If you want to give it more, you got to go back to the deployment, or the stateful set, whatever your replication is generating your replication controller, and say, okay, give it more. But that kills the running process, and you have to start over, and that's not good. So what you need to do is, or what DRA says is, okay, you can actually change the resource allowances on the pod without having to redeploy the pod. So that gives you the ability now to scale up and scale down. What was really interesting in the SIG-Auth update was, okay, if I can update that, how do I authorize the ability to do that?
That's exactly where I was going.
And so they built this new, I think it was a request claim template, something like that gives you a layer of authorization on top of RBAC to be able to limit who can make those request changes. Because the thing is, you're not going to have a human, you're going to have a machine. Right. Yeah.
And you have to be careful because those resource allocations were there for a reason.
Exactly. So it's one of those things that you want to be able to, you might not want to allow your users to. Like you might have user admin, right? Because like a lot, especially in multi-tenant clusters, I as a application owner, can make these API calls on my own, right? I might be doing it through a dashboard or using KubeCon, but you might not want a human to be able to do that. You might only want the machine to be able to do that. So that gives you the ability now to give you a little bit more fine-grained control, the sort of thing that prior to that you would have to use an emission controller, and then you're talking about something like Cedar or OPA or something like that to be able to make that kind of decision.
Okay, last question. You were here doing a book signing. What was the book called?
Oh, so the name of the book was Kubernetes, an Enterprise Guide, third edition. It is from Packet Publishing. You find it on Amazon. I think if you get it from Amazon, if you get the Dead Tree from Amazon, they give you the ebook for free. It's DRM free. And so we talk a lot about not just Kubernetes, but you run Kubernetes. In order to run Kubernetes, you got to integrate with a lot of stuff: monitoring, storage, networking, identity, authentication, access management, meshes, GitOps. There's 24 technologies you need to know to get a modern cluster working. And so we actually spend more time on what it means to integrate with those things than specifically on things in Kubernetes, like what's a manifest, it's not really a book for beginners. It's a book for once you're getting to more of that mid to expert level. So we were over at B Cluster's booth doing the signing because one of our chapters is on B Cluster, and so we start off with kind of the lower level primitives where we get into what is Kubernetes, a little bit of Docker and containers, and then we get straight into some advanced topics in networking around load balancing, services, ingress, and then once we global load balancing, and then once we get past that, we get into authentication, authorization, a little bit about machine identity. Then we start talking about secrets management, and we start building up, right? So each chapter at that point becomes a buildup of the last. So we start with authentication. When we get to secrets management, we talk about how we authenticate the secrets management. Then we go into virtual clusters, which is a way of deploying Kubernetes in a virtual way so that you don't have to have these physical clusters all over the place. But then you have another way of authentication that you have to start talking about. And how do you get the secrets from there into, how do you get your secrets into those virtual clusters to start working with it that way? And then we build up into monitoring, and then we finish the whole book off with building a multi-cluster platform for developers with like GitLab, Argo, Harbor, and Pulumi.
Awesome. Well, we're going to put a link to the book on Amazon right under the episode.
Cool.
After it publishes. So that's episode 51.75. There might be a 51.875 tomorrow. We'll see. With that, I'll say thank you, Marc. Thank you, audience, and we'll see you later.
Thanks, Mike.